Good morning, all you cool cats and kittens, and welcome to another episode of the Science TV with Mr. C. I am your host, Mr. C. Let's get her at her. So, today, 8th grade science. Here's what we're going to do. We're looking at review ionic bonds by going through this. There's also Chatter Doc there if you want to stop and ask questions about any other previous assignments, or maybe what's going on in the future, or just to check in. Here's our link. Good morning, all you cool cats and kittens, and welcome to another episode of Science TV with Mr. C. I am your host, Mr. C. Here's what we're going to work on today. We're going to review ionic bonds by going through this presentation. As we bring it up, it is over ionic bonds. We've talked about this before. We've done a couple of exercises, but I just wanted to kind of reiterate and reinforce this information. Today we're going to look at how they're formed. We're going to talk about the forces that hold them together, and how the structure of the ionic compound relates to its formula. So in this box, we have two negatively charged ions. We're going to drag them closer to each other to see what happens. So both of them are negative. You can see they are repelling. This one's basically pushing the other one around. They do not want to come in contact with each other. Works both ways. Now, we're going to look how ions with opposite charges behave. We're going to try moving this negative one closer to the positive one. We'll see what happens. See right there, I'm not moving it, and it's now dragging the positive ion together. So they are sticking together. Opposites attract. Now we're going to use this information to build upon how ions are formed. Again, remember, ions, opposites attract. They stick together. Alike charges repel each other. In order to build an ionic compound that sticks together, we need both opposite charges, negative and positive. Positive ions come from metals. They have a tendency to lose their electrons. So the positive ion would usually be a metal. Again, metals are always on the left side. Non-metals, since their properties are the opposite of metals, tend to gain electrons. This makes them the negative ion, non-metals. Notice our group right here. The noble gases. They don't gain electrons. They don't lose electrons. They don't share electrons. They are stable. So far, we covered that metals form positive ions by losing electrons. Non-metals form negative ions by gaining electrons. Therefore, metals and non-metals can bond together by forming an ionic bond. Opposites attract. Negative, positive. Opposites, they stick together. So we're going to look at this process and how it works. Let's choose sodium as the metal, chlorine as a non-metal, salt, sodium chloride. Chlorine atoms have a strong attraction for electrons. Under certain circumstances, a chlorine atom will be able to take one electron from the sodium atom. An electron is ripped from the sodium atom, turning it into a positively charged sodium ion. So when sodium loses an electron, it is a positively charged sodium ion. Chlorine gains the electron and becomes negatively charged. This ion is called chloride. Remember, we dropped the second syllable of chlorine and replace it with IVE, chloride. So you can see here, they're shedding the electron. This gets a little bit smaller because it drops down energy level. This one gets a little bit bigger because it has more of an energy level. Since they now have opposite charges, sodium plus, chlorine minus, they are attracted to each other. This bond is called an ionic bond. Chlorine in the atmospheric condition, found in pairs, is called a diatomic molecule, is a gas. Sodium, as we've seen some videos from, it comes in a solid. It's very soft. Cut it with a knife. It reacts violently with water. Usually, it is solid. Each chlorine atom in the Cl2 molecule, since it's a diatomic molecule, needs one sodium atom to react with. So if you have two chlorine, you need two sodium for it to work. So they stick together there, and they're happy. End result is that each sodium ion is combined with one chlorine. One chlorine, one sodium. Now, opposites attract. Each side of this molecule has a charge. Positive ions will attract any negative ions around them, just as negative ions will attract any positive ones. So what ends up happening is they stick together. Start forming larger and larger substances. Many ion pairs will spontaneously self-assemble into an ion crystal. See, they're all lining up here, sticking together. Repeating pattern. Chlorine, sodium, chlorine, sodium, chlorine, sodium. We start getting three dimensions. Looking like this. If you've ever seen salt, it's a cube form. That's because of the crystal alignment of the sodium and chlorine package. In the 3D model, each ion is surrounded by oppositely charged ions. No distinct molecules. They're all alternating. So to calling this compound a molecule, we call it an ionic crystal. Now let's look at what we do, how to write some formulas. Here's the crystal again. We're going to tap each ion below to count the number of sodium ions and chlorine. Sodium, we'll start with first, Na. This is the Na. This is one. This is one. 3 sodium ions. Next we'll go to the chlorine. 1, 2, 3. 3 sodium, 3 chloride. Since we write chemical equations in formulas, we're going to get down to the lowest common number. We're going to simplify. We're going to reduce. This is a 1-to-1 ratio. 3, 3. Well, we can divide them both by 3 to get 1. So sodium chloride is a 1-to-1 ratio. No molecules in this ionic crystal. Ionic compound tells us the ratio, not the total number of them in it. So the salt you have, if you have at home, NaCl is the ratio of sodium to chloride, not how many atoms are actually there. We're going to rotate this crystal. A little more practice. See, there's 4 yellow in front, 3 in the back, and then if we flip it over, there's another gray there, and 4 more yellow. So we have a total of 8 yellow, 8 chlorine, and I count 4 calcium. Right? Check it out. Check. Looks good to me. Crystal is, that's not the formula though. Remember, we can reduce 4 and 8. Divide them both by 4. There. Here's the actual formula. Calcium fluoride ratio is 4 to 8. We reduce it to 1 to 2. Therefore, we write the formula like this. If you remember back to the ionic bond review, calcium has a 2 positive charge. Fluorine has a negative 1 charge. So, it kind of works out there. So in this tutorial, we learned the following. We know how ions are formed. We know why they stick together. And we know how to write an ionic formula. That's it. We're finished for today. We'll see you again Wednesday. Thanks for watching.